Welcome to Understand the Math. In this video, I'm going to teach you how to solve quadratic trigonometric equations and walk through 3 example problems. Before you begin, be sure to check out the video description below for a link to free guided notes that you can download and fill in as you watch this video. In the 3 example problems that we're going to solve, we will find all solutions, and then we'll find all solutions for theta from 0 up to 2 pi. The strategy that we're going to use is to write each equation as ax squared plus bx plus c, factor it, and then replace the x with the trigonometric function. There are 5 steps that we can follow to solve these equations. The first step that I mentioned above when we talked about the strategy is to write the equation as ax squared plus bx plus c is equal to 0, factor it, and then solve it. The second step is to replace x with its trigonometric function. The third step is to determine the quadrants for theta. The fourth step is to plot the value of sine theta, cosine theta, or tangent theta on the unit circle. And then the last step is to find all solutions for theta. We'll use reference angles to find our solutions for theta, so I've included a chart here that we can use as a guide. In our first quadrant, our angle is equal to our reference angle. In the second quadrant, our angle is pi minus our reference angle. In the third quadrant, our angle is pi plus our reference angle. And then in the fourth quadrant, our angle is 2 pi minus our reference angle. Let's make a note that sine theta and cosine theta range between -1 and 1. So if sine theta or cosine theta is equal to a value less than 1 or greater than 1, we're not going to have a solution. And then let's also remind ourselves that tangent theta can range between -infinity to infinity. So with tangent theta, we'll always have a solution. Let's now walk through our 3 example problems. For all 3 problems, we're going to find all solutions to the given equation, and then we're going to find solutions in the interval from 0 up to 2 pi. The first equation that we'll solve is 3 sine squared theta minus 7 sine theta plus 2 is equal to 0. We'll begin by letting x equal sine theta. Plugging this into our equation, this gives us 3x squared minus 7x plus 2 is equal to 0. We then factor this equation, so we have a 3x and we have an x. We need a 2, so this we'll put the 2 here, the 1 here. We need a minus 7, so both of those are negative. This gives us 3x minus 1 is equal to 0, and it gives us x minus 2 is equal to 0. So we have x is equal to 1/3, and then x is equal to 2. Let's now replace x with the trigonometric function. So x was equal to sine theta. So this gives us sine theta is equal to 1/3, and sine theta is equal to 2. Once you get used to solving these, you don't really have to go through the step of replacing sine theta with x. You can jump right to factoring it directly as 3 sine theta minus 1 times sine theta minus 2 is equal to 0. In our second step, let's make a note that theta is equal to arc sine of 1/3 for our first equation. And then for our second equation, let's notice that sine theta is greater than 1. And sine theta can never be greater than 1, so we're going to have no solution for this equation. When sine theta is 1/3, it's positive, so theta is going to be in quadrants 1 and 2. And then as I mentioned above, because sine theta is greater than 1, we're going to have no solution. In our first quadrant, theta is going to be the arc sine of 1/3. When we put this in our calculator in radian mode, this is equal to 0.3398. In our second quadrant, theta is going to be pi minus theta sub r. So this gives us pi minus 0.3398. We'll squish it in here. So this gives us a value that theta is approximately 2.8018. For all solutions for theta, theta is approximately 0.3398 plus 2n pi, and then theta is approximately 2.8018 plus 2n pi. Between 0 and up to 2 pi, we get a value of 0.3398 and 2.8018. And we'll remind ourselves n is 0 plus or minus 1 plus or minus 2. If you're finding this video helpful, please give it a thumbs up and consider subscribing to my channel. The second example that we'll look at is 2 cosine squared theta minus 3 cosine theta plus 1 is equal to 0. We'll first let x be equal to cosine theta, and that gives us 2x squared minus 3x plus 1 is equal to 0. We'll factor this. So we have a 2x, we have an x, and then we have a 1 and a 1, and we need the 3x to be negative. So these are both negative. This gives us 2x minus 1 is equal to 0, and x minus 1 is equal to 0. So we get x is 1/2, and we get x is 1. We'll then replace x with cosine theta, and we have cosine theta is 1/2, and then cosine theta is equal to 1. We'll remind ourselves that theta then is the arc cosine of 1/2, and theta is the arc cosine of 1. For our first value for theta, cosine is positive, so theta is going to be in the first quadrant and the fourth quadrant. For our second equation, cosine theta is 1, so theta is going to be located at a coordinate point. For our first equation, theta is arc cosine of 1/2, and this is equal to pi over 3. And in the fourth quadrant, theta is going to be 2 pi minus our reference angle, and let's just note that this was our reference angle back in quadrant 1. So our theta is going to be 2 pi minus pi over 3, and that gives us a value of 5 pi over 3. For our equation on the left, theta is then equal to pi over 3 plus 2n pi, and then 5 pi over 3 plus 2n pi. Between 0 and 2 pi, theta is pi over 3 and 5 pi over 3. For our equation on the right, cosine theta is equal to 1. Cosine's related to x, and x is equal to 1 at this point, so we see that theta is going to be equal to 0 plus 2n pi, and between 0 and up to 2 pi, our theta is going to be equal to 0. And lastly, we'll put in our value for n. This is the last equation that we'll solve, and it's much more difficult than the other two. It involves tangent, and you might notice that it has a fourth power in it. We'll begin just like we did with the first two examples. We will let x be equal to our trigonometric function. So we start by saying that x is equal to tangent theta. This gives us x to the fourth minus 13x squared plus 36 is equal to 0. We can factor this in terms of x squared. So we have an x squared here, an x squared here, and we look at factors of 36. So there's 6 and 6, that won't work. There is 9 and 4, that's going to work. So we have an x squared minus 4 and an x squared minus 9. So this gives us x squared minus 4 is equal to 0, and x squared minus 9 is equal to 0. So on the left, we have x squared is 4. That gives us x is equal to, we have to pay attention, we need to make sure that we do a plus minus. So x is going to be plus or minus 2. And then on the right, we have x squared is equal to 9. So we have x is equal to plus or minus 3. Let's now replace x with our tangent theta. So this gives us tangent theta is plus or minus 2 on the left, and tangent theta is plus or minus 3 on the right. We're going to combine these to talk about the quadrants. When tangent theta is positive, our theta is going to be in quadrant 1 and quadrant 3. We don't really need to worry about quadrant 3 because tangent is pi periodic, so we can pick up the solution in quadrant 3 from the solution in quadrant 1. When tangent theta is negative, our theta is going to be in quadrant 2 and in quadrant 4. And in a similar way, we don't need to worry about quadrant 4 because we can pick that up from our solution in quadrant 2 since tangent is pi periodic. Let's first look at when theta is in quadrant 1. Our theta is going to be arctan of 2. I've written it here because I know that arctan of 1 is pi over 4, so it has to be between pi over 4 and pi over 2. And then we have theta is equal to arctan of 3. Let's write down below here where we have more room that arctan of 2, when we plug it in our calculator in radian mode, is 1.1071, and our arctan of 3 is approximately 1.2490. Now let's talk about theta being in quadrant 2. This is when theta is negative. Let's remind ourselves that our theta sub r, reference angle in our first quadrant, is arctan of 2, and we have theta sub r arctan of 3. For this solution right here, theta is going to be pi minus arctan of 3. We're kind of a little squished here. And for this solution, theta is going to be pi minus arctan of 2. We'll write down here that pi minus arctan of 2 is approximately 2.0345, and then pi minus arctan of 3 is approximately 1.8926. Let's now summarize our solutions. Theta is going to be 1.1071 plus n pi, and then it's going to equal 1.2490 plus n pi. Between 0 and 2 pi, we're going to have 4 solutions, and those solutions are going to be 1.1071, 1.2490, and then adding pi to both of those gives us 4.2487, and then lastly 4.3906. For our solutions from quadrant 2, theta is going to be equal to 1.8926 plus n pi, and then 2.0345 plus n pi. And our four values will then be 1.8926, 2.0345, and I'm going to put the other two up here. They're going to be adding pi to both of those values, and that gives us 5.0342 and 5.1761. That was a hard problem, but we did it. You might want to watch the next video in this series. It's the last one for solving trigonometric equations, and it's on using identities to solve trigonometric equations.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.